Today I want to show you a more tricky integration by substitution, something which can be a little bit more difficult. So it's an additional part to the previous video I made, as I didn't cover these cases. So first start with this one. Let's do this one, number one. This one is still normal, not difficult. So we compare it with this, and you will notice necessity of different approach. So let's find the u. Here we have integral x or square root 3x squared plus 2. Then u equals 3x squared plus 2. And in that case, du will be 6x dx. Because we have 2 here. So say we move 2 before the number. So we have 2 times 3 is 6. And we make 2 minus 1, which becomes x to the power of 1, which is 1. I mean, not 1, but the number, right? It's going to be the number it is. Yeah, so it's going to be just x. X to the power of 1 will be x. So it will be 6x. So you have du 6x dx. Then dx equals du over 6x. And then you can rewrite this integral as x square root u over du and 6x. And this way, this x will cancel out. We'll have only 1/6 before the integration symbol. We write 1/6 here. And we'll have square root u. And later you will change the square root u to 1/2, and it will be easy to solve, right? But it's not that easy in this case. Let me show you why. It was much easier here because we had 3 to the x squared, x to the power of 2, which derivative becomes easily to cancel. You have x in derivative and x here. That's why you can cancel them out. How about this? Okay, so let's say what is u here again? We write u is not 3x squared, but u is 3x plus 2. Then du will be 3 dx. Right? We don't have x 3x like here. So we have 6x because according to the derivative power formula, by default we have 1 here. X is by default like x to the power of 1, although we don't see this exponent. So this 1 u minus 1, it becomes x to the power of 0, which is 1. And if you move 1 before, it's just 3. So 3 times 1 is 3. So we have only 3 left. And then what's going to happen? Dx equals to dx equals to du over 3. And then let's rewrite it. Okay, so we have integral x square root u du over 3. And what can we do? You see, you have x here and here we have 3. We cannot eliminate this x, which is necessary for our further calculation. Therefore, it's not enough to just calculate du as we used to do it before. What we need to do in this case, we need to look at this u, and from this short equation here we need to extract what is x, and we'll replace x with a u. So we'll do an additional substitution. We'll solve for x, and then we'll be able to solve this integral. So let me just erase the part which was troublesome. I'll just erase this one. Of course, we need to write what is u. I will write again what is u. So we write that u equals to 3x plus 2. But I will also write what is 3x equals to u minus 2. Right, and from this we can divide it by 3. Then we have that x equals to u minus 2 over 3, which is the same as a third times u minus 2. Okay, and look what's gonna happen. We also write, now we can also write du equals 3dx from derivative, right? This is du is derivative of u times dx. And now with this information you can rewrite this integral to this format. Okay, like that. It's gonna be here you're gonna write just what is x. So instead of x here we'll write that. So we write 1/3 u minus 2 times square root u du. And from this we can already solve this integral. I'm not gonna solve it, you can solve it yourself. We additionally write a du divided by 3, because we wrote what is du, but we also need to say what is dx. Dx equals du over 3. And from this you'll be able to solve this integral. I have also a similar one which is quite difficult here, so let's solve it step by step. 1 over 2 plus x. So from this we know that u equals 2 plus square root x. Then we know that du equals 1 over 2 square root x. And from this, dx equals 2 square root x du. Let me explain why. As you can see, u is 2, this one in the denominator. We take this whole function as u to make it simpler. And then we calculate the derivative from this. So we need to calculate a derivative of 2 plus square root x is the same as 2 plus x to the power of 1/2. Right? Because square root x is x to the power of 1/2. And from this, you apply the power rule for derivative. You will calculate derivative from this expression. We will ignore the constant. We're going to ignore this 2. It doesn't matter here for the derivative. So what we're going to do, we do something like we take x and then we take 1/2 minus 1. And we move, of course, we move this exponent here. as well. That's the power rule for derivative, which I taught you in a previous video, which says nx n minus 1. That's how we calculate derivative. So this n exponent goes before the number, and we reduce exponent by 1. That's what we did exactly. And from this, we're gonna have 1/2 x to the negative half in exponent.